Welcome. This video will cover one very nice. I'm really careful here about using words. Nice is kind of, efficient. Very efficient method of analyzing engineering alternatives economically or comparing between multiple of them, which is the annual worth method. So in the previous parts, we introduced present worth, future worth, and the requirement to use or apply least common multiple planning horizon when you compare between alternatives of different useful lives. Annual worth is nice in the aspect that it actually frees us from that. It doesn't require LCM. So annual worth method, it's a kind of getting an equivalent cash flow that's similar or equivalent in value to the original cash flow, but that equivalent cash flow is in the form of a uniform series that spans and covers the useful life of the asset. So the or the alternative. So if there is alternative that has cash flows up and down, positive, negative over 20 years, different values, different shapes, different patterns, annual worth method will represent that cash flow that spans over a number of years, let's say 20 years, with a 20 years cash flow, but with a uniform series of value that we call annual worth or A, that's equivalent to the original cash flow. So it's good because it's now if I compare between two alternatives, I can compare between the annual worth of that, which let's say says the annual worth of alternative A is $50,000 a year, and then for alternative B it's like $45,000 a year. Both of them are positive values, so it's kind of an annual comparison now. 50,000 versus 45,000. I'll pick the one that gives me more return. So that's kind of an apple-to-apple comparison. In the present worth, it was apple-to-apple comparison by bringing the value or worth of the cash flows to the present, and I'm calculating that big number in the present. And the future is similar way, but in the future point of the cash flow. But now the annual worth is kind of melting or getting that equivalence of the cash flow over years. And one thing here also that it's called annual worth because most cash flows are annual, but some cash flows like monthly or quarterly. So you still will apply annual worth, but it's not really annual now. It's a uniform series worth, depending on the time period you use in this cash flow. So that's kind of something to pay attention to. Annual worth is applicable, and it's the same process when you have monthly or quarterly or weekly cash flows. So one last thing here is you will not be required to use the same planning horizon because you are representing your cash flow on an annual basis. So it doesn't matter if the cash flow you're representing is 20 years, 30 years, you're kind of representing that as an annual equivalence. So you don't have to go through that check of multiple, different useful lives for alternatives and bringing everything to an LCM planning horizon for all alternatives. So this means you just jump directly into analyzing every cash flow. You don't have to repeat cycles of investments or buying and selling equipment and all that. It's just single cycle of a cash flow. So let's illustrate that with this example here. So this bakery is evaluating two alternatives of ovens, two models, and you have the oven or the bakery here has a minimal attractive rate of return. The way they secure the capital is that it's costing them 8% per year. So which one should be which model should the bakery here purchase? So we will use annual worth as an exercise here. So as we are using annual worth, there is no need to use LCM or apply the same planning horizon. Let's keep model 334A is the same as 5 years, and the other one is 10 years. So let's start with the first one, 127B, and that's over 10 years. I have initial investment and I have a maintenance cost, and this model will give me more production here value of annual income of 19,400, and at the end I will have a salvage value of $10,000. So by looking here, I will have, you can say, initially 4 components. The first component is yes. So 50,000, it's a cost, initial cost, and I'm calculating the annual worth. So it's multiplied by A given P, the 8%, and then I have 10 years. Next would be the uniform series that I have, which is the income and the annual expense. And because they are already annual series, and I'm calculating the annual worth series of this cash flow, I'm multiplying them by 1. So they're exactly covering the 10 years that I'm trying to get equivalency annual worth for. So I don't have to change them. It's just the same values as shown. And then the final value, the salvage value, is brought from the future to the annual worth. So it's A given F, 8% and 10. So we can use the factors or the tables and just writing the final values here. You can note here that I kind of got the net uniform series of 9,400 out of the 19,400 income and 10,000 annual expense. So I end up here with positive annual worth here of 2,639. This means that the bakery, if they decide to use model 127B, they will get back a return that's 8% and even more. So they will get maybe 9%. We don't know. We will learn about this in internal rate of return. So this is the first model. The second model, I don't have to extend it over 10 years. Just one cycle of it is enough because I'm using annual worth. And I have here the initial expense, 80,000, A given P, 8% and 5 years. And then the 2 uniform series cash flows of income and expense. And they are uniform series of 5 years, which complies with what I'm trying to calculate. So it's multiplied by 1. And then I'm done. I have all the values, all factors, and I end up with annual worth here of negative 36.8. Negative here means that if bakery decides to buy that, they actually will be losing money, kind of, because their minimum attractive rate of return is 8%. This model will not be able to recoup or recover that cost of investment or cost of capital that they will have. So in this case, you will decide to say, of course, pick the one that makes them profitable, which is the first model. One thing we'll do here, which you don't do, I will just show because you don't trust me why we don't LCM or don't extend the second model for 10 years and compare now fairly. Let's do that. Let's actually do, ignore that you're actually taking my advice. And now you're doing model 33.4a and repeating the cycle of its life twice. So it's now 10 years, same as the first model. And if I use now the annual worth calculations, so of course I will now kind of use the uniform series that I'm giving as just extending over 10 years and not discontinuous here. So I will have here the initial investment, A given P, 8%, but now not 5, I'm analyzing 10 years. And then the uniform series of income and expense will be multiplied by 1. I'm left with one interesting one, which is the 80,000, the investment of the second cycle for this model of oven. And that one is interesting because I have to bring it to the present and then use that present to calculate the annual worth or annual value series of it. So it's kind of 2 factors here. You have to bring it where the 80,000 initial one, the first one, is, and then multiply by the same A given P factor that I used for that one. So it's multiply P given F, 8%, and then bring it from the beginning of the first cycle, which is 5 years, and then multiply by A given P. So if I bring the values of the factors and calculate present worth in the other alternative way of calculating it, present worth prime 2, that will be very close to what the one I calculated before because of the rounding error from using different factors or different formulas. So this is just a proof that you have to listen to me. Kind of. This is what I tell my kids. But really, it's just a wasted effort if you use LCM when you apply annual worth. Why you do a second cycle if you get the same answer? So when you use annual worth, please don't apply least common multiple and unify the lives of these cash flows. Just stick to what's given to you, and you will end up with still the same value that will help you to end up with the correct economical decision here. So that's the end of this video. I'll see you in another video which will cover how we can compare between alternatives using a very cool method, which is internal rate of return. I'll see you then. Take care.